In this video, I will go over Lesson 14 Practice Problems, your homework. Alright, so problem number 1. You are asked to complete the table with all of the missing information about 3 different cylinders. Okay, so let's recall what we know about the volume of a cylinder. We know that the volume of a cylinder, it's the area of the circular base times the height. And the area of a circular base, the formula for that is pi times the radius squared, and then the height, we use a lowercase h to represent that. So this is the formula for the volume of a cylinder. So we will use this information to figure out the missing information on the table. So for the first row, the diameter of the base is 4 units. They're asking for the area of the base for this one. So let's see. The area of the base, we know it's pi r squared. So we have to know r, the radius. And we know the radius is half the diameter. So if the diameter is 4, r is 2. So now we can plug in 2 in place of r. So we will have, for the area of the base, you will have pi 2 squared. We will simplify that. 2 squared is 4. So the area of the base would be 4 pi. And you're given the height. The height is 10 units. The volume, it's just the area of the base times the height. So the area of the base is 4 pi times 10 units for the height. So 4 pi times 10, the volume is 40 pi. Okay? Now for the second row, the diameter is 6, so we have to figure out the radius. The radius will be half of that. So half of 6 is 3. Now that we have the radius, we can figure out the area of the base. That will be pi times the radius squared, so 3 squared. So that will be 3 squared is 3 times 3, so we have 9 pi. So 9 pi is the area of the base. You have to figure out the height. The volume is 63 pi. So we know that to figure out the volume, you have to multiply 9 pi by some number to give you 63 pi. So you can do it mentally. You can think of a number times 9 pi equals 63. And you know that's going to be 7. 9 pi times 7, 63 pi. So the height of this cylinder is 7. Or another way to do it is to divide 63 pi by 9 pi. So you're going to do 63 pi divided by 9 pi. And you're going to get the same thing. You're going to get 7. So the height of the cylinder is 7. All right. The next row. So you're given the area of the base is 25 pi. So to figure out the volume, we just have to multiply the area of the base times the height. So 25 pi times 6, that would be 150 pi. Now to figure out the diameter, first we have to figure out the radius. So we can write this 25 pi in the form pi times r squared. And if you do that, you're going to see that this is the same as pi 5 squared, because 25 is the same as 5 squared. So we know that the radius is 5. So r is 5. Therefore, the diameter would be 2 times of that. That will be 10. Okay? All right. Problem number 2. A cylinder has a volume of 45 pi and a radius of 3. What is the height? So let's write down what we know. So V equals 45 pi. The radius is 3. The height is unknown. That's what we're trying to find. So get started by writing down your formula. V equals pi r squared times height. So the volume is 45 pi. 45 pi. Bring down the pi. And then r, the radius is 3. So 3 squared times the height. So by inspection, one way you can do it is by inspecting this thing. You can see that 3 squared, that's really 9. And then this is h. And you have 45 pi. So by looking at it, you're going to ask yourself, 9 times what equals 45? And you will get that will be 5. So the height is 5. Another way of doing this is by solving it algebraically. So from here, I'm going to do 45 pi is equal to 9 pi times h. Solving for h, I have to get rid of 9 pi. We know that this is multiplication. This is 9 pi times h. And we undo multiplication by dividing, by division. So we will divide both sides by 9 pi. So no more 9 pi on the right side. That's gone. You only have h. And then you're going to divide this. That's going to be 1. 45 divided by 9 is 5. So the height of the cylinder with a radius of 3 and volume of 45 pi, the height of that is 5 units. Okay, problem number 3. You're given 3 cylinders and each have a volume of 2,826 centimeter cube. So let's kind of break it down here. So we have cylinder A, cylinder B, and cylinder C. So the height is 900 for A. For B, the height is 225 centimeters. And for C, the height is 100 centimeters. Okay, so again, the volume for each is 2,826 centimeter cube. So let's write down the formula for the volume. V equals pi r squared times the height. So the volume is 2,826 equals pi r squared. That's what I'm trying to figure out. And then we will plug in 900 for the height times 900. Okay, you know you have to solve for r, so you have to get rid of pi and 900. In this case, I'm gonna do it one at a time. This means pi times r squared times 900. I will do the 900 by dividing both sides by 900. So this 900 is gone. Now you only have pi r squared. And when you divide 2,826, you divide that by 900, you are going to get, so 2826 divided by 900, you will get 3.14. Now to solve for r squared, you have to get rid of pi. So we will divide both sides by, instead of dividing it by pi, we will use 3.14 as an approximate value for pi. So be 3.14, 3.14. So now we will get r squared is equal to 1. Okay, now, again, you're going to ask yourself, what number times itself equals 1? So you're going to do r times r equals 1. So we know r equals 1. So the radius of this cylinder is 1 for cylinder A. So let's box that. Now let's move on to cylinder B. So let's write down the formula again. B equals pi r squared times the height. The volume is 2,826. Pi, the radius, I don't know, that's what I'm trying to find. And then the height is 225. So I will do the same thing. First, I will divide both sides by 225. So this is gone. Now I only have pi r squared. And 2,2826 divided by 225 is equal to 12.56. Okay, so again, you have to solve for r. You have to get rid of pi, so you will divide both sides. Instead of dividing by pi, I will use 3.14. So divide both sides by 3.14. Now I'm going to have r squared. So that's gone. We're going to divide 12.65 divided by 3.14. 12.56 divided by 3.14. You will get 4. So 4 equals r squared. So again, you can take the square root of both sides. Or you can ask yourself, r times r equals 4. What number times itself equals 4? R equals 2. So the radius of cylinder B is 2 centimeters. Okay, cylinder C. So again, V equals pi r squared times height. The volume is 2,826. Pi, the r is, that's what I'm trying to find. The height is 100. So I will do exactly the same thing as over here. I will divide both sides by 100. So I'm going to have pi r squared. 2,826 divided by 100 is 28.26. And then again, I'm solving for r. I have to get rid of pi. I will undo multiplication by dividing both sides by 3.14 because that's what they want me to use for pi. So now I'm going to have r squared is equal to, when you divide 28.26 by 3.14, you will get 9. So now you have 9 equals r squared. So again, ask yourself, what number times itself equals 9? So that is 3. Or you can just take the square root of both sides. Either way, you will get the correct answer. So the radius of the cylinder is 3 centimeters. Alright? Okay, move on to the last question. So you're given a graph and they have some questions that you will answer based on the graph. So here's a graph that shows the water height of the ocean between September 22nd, so September 22nd, and September 24th in Bodega Bay, California. So let's see. For question A, estimate the water height at 12 p.m. on September 22nd. So September 22nd is right here at 12 p.m. Let's see, what's the water height? Okay, it's more than 3. It's like in between 3 and 4. So it's about 3.5 feet. Question B. How many times was the water height 5 feet? Find 2 times when this happens. So let's take a look at the graph. So this is the water height. You're looking for 5 feet. So let's see how many points here have a value of 5 for the y. So that's 1, 2, 3, 4. So there are 4 times. 4 times. We have 4 times here. So you can pick 2 times. So maybe this one. I'll pick this one. So this is not exactly 6 p.m. So right before 6 p.m. Maybe I say 5:50 p.m. That's just an approximate. It's right before 6 p.m. And another time would be this one right after 6 p.m. Maybe I say 7 p.m. So this is 5 p.m. 5:50 p.m. on 9/22nd. And the other one is, say, 7 p.m. on, what's that, 9/23rd. Alright, letter C. What was the lowest the water got during this time period? And when does this occur? So the lowest, you're going to figure out what's the lowest point. The lowest point is right here. So that's approximately 1/3. 1/3 foot. And that happened. It's still 9/22nd. Maybe like 11 p.m. 11 p.m. on 9/22nd. Letter D. Does the water ever reach a height of 6 feet? So let's look at the graph. This is 6 feet. Is there any point here on the graph? Nope. No. So it never hit 6 feet. It's right before 6 feet, but not enough. Alright. So that's lesson 5.14 homework. Alright. I'll see you in class.